Welcome again to our initial webinar in the Logistics Viewpoints Technology series. Today we're launching our series with AI in the supply chain. The future belongs to supply chains that think and adapt in real time. Of course, this is excerpted from our significant white paper on the subject. We urge all listeners to go to Logistics Viewpoints and download the white paper, and you'll get quite a bit more than we have time to present here in this webinar. So let's get started. AI has become the new operating system for logistics, as we all know. Supply chains once optimized for efficiency, but they are now built for adaptability, and artificial intelligence really is the catalyst. What we mean by AI in the supply chain is not a dashboard or forecasting tricks. It's a true architectural change. AI, as we know, perceives patterns across thousands or millions of variables. It reasons through uncertainty and acts in near real time. This session today explores how that shift works through four architectures: agent to agent or A2A communications, the Model Context Protocol MCP for shared memory, Retrieval Augmented Generation or RAG for live knowledge grounding, and Graph RAG for network reasoning. Together, these four form a connected intelligence layer that links suppliers, carriers, warehouses, and customers in continuous dialogue. The result is faster recovery from disruption, a better use of assets, and measurable sustainability gains. Over the next hour, we'll translate these ideas into practical strategy, how leaders can move from isolated automation to orchestrated reasoning. The future of logistics belongs to networks that think, adapt, and collaborate. The organizations that master these architectures first will define resilience for the next decade. We'll move through 9 segments today that mirror the ARC white paper. The first is foundations of AI in supply chains, then A2A communications, machines that negotiate, MCP, which is the memory layer, RAG, grounding reasoning in real-time, real-life data, and then Graph RAG, mapping interdependencies between data. We'll discuss data harmonization and infrastructure, challenges and risks, the path forward, and a logical roadmap, and we'll finish our day with conclusion and a Q&A. As you can see, each section builds on the last, showing how these capabilities create a coherent operating model. My goal as presenter today is to connect technology to business outcomes: cost, speed, resilience, and compliance, for example. Keep in mind that every diagram or bullet you'll see ties back to one principle: supply chains become intelligent only when communication, context, and data are all tightly unified. So let's talk about context. Modern supply chains operate under constant strain. Lead times stretch, climate, trade, political shocks occur and reoccur, and customers expect real-time transparency. Traditional systems like ERP, TMS, WMS, well, they excel at recording events, but not reasoning about them. They lack the adaptability to replan when assumptions fail. That's why volatility has become the defining feature of logistics. We open with this context to emphasize that AI is not optional optimization. It's a mechanism for coping with a permanently unpredictable world. By embedding perception and reasoning into each node, at the factory, the port, the warehouse, we can transform reactive workflows into anticipatory ones. The context slide here sets the stakes. Survival now depends on cognitive supply chains that learn, communicate, and act at machine speed. So let's start with the foundation. What AI really means in the context of supply chains. We're not talking here about a bolt-on tool or another dashboard. We're talking about a truly structural shift in how operations perceive, reason, and act. Supply chains used to run on rigid rules and schedules, and they were built for stability. But today, stability is the exception. Lead times are unpredictable, disruptions are routine, and customers expect speed, transparency, and personalization. Traditional systems were never designed for this level of volatility. So that's where AI changes the game. It enables supply chains to see patterns across millions of variables, to understand what's happening now and to anticipate what's next. AI can detect these early signs of disruption, rebalance resources on the fly, and recommend actions before anyone has to ask. Think of it as moving from rule-based automation to adaptive intelligence. Instead of executing predefined workflows, AI systems learn from experience. They recognize anomalies and make context-aware decisions in real time. The impact runs deep, from procurement and planning to transportation and fulfillment. Each node increasingly becomes smarter and each connection more responsive. The phrase I happen to like to use is AI is really a bridge between what we've optimized and what we still need to understand. It's how we move from reacting to events to shaping those events. So as we move through this section, we'll unpack how AI transforms the supply chain from a linear pipeline into a living ecosystem, one that senses, learns, and adapts continuously. That's the foundation, not automation, but true awareness. AI is not a bolt-on tool, as I initially mentioned earlier. It's a full-scale structural change in how operations run. Think of it as the layer that connects data, decisions, and action in one continuous loop. It enables perception of patterns across millions of variables that no human or spreadsheet could ever track. It supports reasoning across changing conditions in real time, adjusting to new market data, supply interruptions, and demand surges as they unfold. In procurement, AI can detect early warnings from supplier lead time fluctuations. In planning, it models alternative production schedules the moment an input changes. And in transportation, it can instantly reroute around weather or port congestion. In fulfillment, it can adapt promise dates dynamically as capacity shifts. The key takeaway here is that AI isn't here to automate yesterday's logic. It's here to replace the rigid, rule-based workflows with systems that, again, sense, interpret, and act continuously. That really is the bridge from static optimization to adaptive intelligence. And what it does is make the solution resilient and fast. So, as we said, legacy systems depend on static rules and linear workflows. If-then logic governs every move. When demand rises, order more. When stock is low, trigger replenishment. AI replaces that rigidity with probabilistic, data-driven learning. Algorithms detect subtle anomalies and anticipate swings before the thresholds break. So instead of a planner reacting to an alert, the model learns the context behind each variation: seasonality, supplier behavior, maybe some macro signals, and adapts automatically. The corrective actions that emerge are not pre-scripted. They're discovered through continuous learning. This shift means fewer surprises and faster recovery from disruptions. The headline for this slide: learning systems thrive precisely where rule-based software fails. When conditions deviate from the norm, it's a mindset change. We're moving from programming instructions to training intelligence. Let's talk about real-time optimization. AI optimizes those decisions across all those variables simultaneously. Fuel prices, traffic, weather, labor capacity, shipment status, then recalculates the most efficient combination every few minutes. Transportation routes adjust dynamically to minimize cost and delay. Procurement strategies shift proactively when a supplier or region becomes risky. This scale of computation allows for decisions that are faster and more comprehensive than any manual process or ones that any human can do. This near real-time optimization converts complexity into advantage, and instead of fighting uncertainty, the system exploits it for performance. The phrase to really think about and drive home here is optimization at scale. When you can make and test thousands of micro decisions per hour, you turn volatility from a liability into a true differentiator. Visibility across systems. Today's supply chains are increasingly exception driven. Managers spend their days chasing deviations instead of executing plans. AI changes that dynamic by predicting exceptions before they happen and initiating resolution workflows automatically. So, say when a threshold is exceeded, a late shipment or a temperature variance, the system knows which teams to notify and what corrective actions to propose. Human escalation happens only when confidence is low or the stakes are high. Every iteration of this loop improves future accuracy and efficiency because the model learns from those past outcomes. The essence here of this slide is that managing exceptions well has become the true measure of agility. AI delivers the foresight and the underlying automation needed to stay ahead of these exceptions and not just react to them after the fact. Now remember, it's not the be all and end all. AI augments rather than replaces human expertise. Dashboards and recommendation engines give operators context-aware insights that they can truly trust. Humans do, in fact, though, remain in control of judgment, ethics, and prioritization, while AI supplies the speed, the pattern recognition, and the precision. Operators can intervene selectively, approving high-impact decisions or fine-tuning parameters, while allowing validated systems to run on autopilot. This human-in-the-loop approach ensures domain knowledge is preserved even as automation scales upward. The most effective supply chains combine that machine speed with human judgment, producing decisions that are both fast and sound. The emphasis here is that collaboration, not replacement, is the model of the future. And with that foundation behind us, let's move on to section 2, agent-to-agent communications. So this section introduces A2A, or agent-to-agent communications, as a mechanism that lets machines collaborate directly inside a supply chain network. Up to now, AI has mainly optimized isolated functions, planning, transport, inventory, but A2A links them all. It enables software agents, each representing a unique business role, such as procurement, transportation, inventory, or demand, to share information with each other and to make decisions without waiting for manual approval. Think of dozens of intelligent agents constantly exchanging data, shipment status, supplier updates, forecast changes. Each agent can then evaluate options, negotiate with its peers, and execute an outcome in minutes or seconds. This is truly system-wide intelligence in motion. All of us today should really understand that A2A is not one product, but an architectural layer that replaces slow human handoffs with instant digital negotiation. It's the nervous system that ties every AI-enabled node together, unlocking the ability for the supply chain to reason as one organism rather than many disconnected parts. So what is A2A? Let's define it. It enables direct interaction between AI agents. These agents request and share information dynamically. meaning the data exchange happens in real time and is context driven. They negotiate options and execute cross-functional decisions automatically. The functions covered include procurement, transportation, inventory, demand management, and more. Imagine a procurement agent that learns supplier behavior, communicating directly with a transport agent monitoring port congestion. Together, they can decide to shift an order before a disruption strikes. Each bullet on our slide illustrates how communication itself becomes the infrastructure. When agents can talk, decisions can flow seamlessly across the domains. The essence here is that A2A removes the latency from cross-functional human coordination. Instead of emails and spreadsheets, machine agents can collaborate continuously and quickly, ensuring that every action, a reorder, a reroute, a reschedule, fits within the network's overall objective. Agents that talk to each other truly unlock system-wide intelligence. So why does A2A matter? Well, traditional enterprise communication is rigid and manual. A planner sends a message to procurement. Procurement alerts logistics. Hours or days pass before corrective action begins. In that delay, customer service suffers and costs rise. A2A eliminates this drag by allowing machines to coordinate directly. Disruptions that once cascaded slowly across your silos are now resolved in minutes or seconds. And when this delay is detected, agents across functions can reoptimize those routes, sources, and inventory simultaneously. The result is faster, more coherent response and fewer lost opportunities. For customers, that translates into increased reliability. They see a company that anticipates instead of apologizes. The key message here is speed through autonomy. A2A achieves what humans cannot: instant system-wide reaction to change. And that speed is a new competitive edge. So each bullet here represents a practical example of this autonomy at work. Dynamic replenishment, where demand and inventory agents coordinate to balance stock across distribution centers in real time. Or procurement automation, where agents issue RFQs, evaluate bids, and place orders when thresholds are met. Or routing optimizations, where transport agents bid for lanes dynamically, weighing cost, service level, and emissions. Or exception management, where agents handle minor issues autonomously and escalate only when confidence drops below a certain level. So think about these recognizable operations. A2A truly transforms replenishment, routing, and sourcing from these reactive processes into living, self-adjusting systems. And these are not futuristic pilots. These are all early examples of continuous digital coordination already appearing in leading logistics networks. So what are some benefits? Well, I think we've touched on a few already, but the benefits mirror what every executive voices as a want and a need: speed, scalability, adaptability, and savings. A2A cuts those manual handoffs and approval loops, collapsing cycle times. These dozens of agents can operate concurrently across the network, each improving throughput in its domain while sharing its results with others. And because these agents are modular, the architecture can evolve without wholesale replacement. New capabilities can simply plug in. The financial impact follows naturally: better asset utilization, optimized carrier selection, and lower administrative overhead. The broader point is that autonomous coordination does more than reduce cost. It increases organizational agility. When markets shift, your digital workforce of agents adjusts instantly as well, keeping your operations aligned without waiting for a crisis meeting. This is how AI delivers both efficiency and resilience at scale. So what's happening in the development world? Open agent architectures are aiming for interoperability in supply chains. Multi-agent systems, as we discussed, are beginning to support manufacturing as well as logistics. Cloud platforms are being released that embed these A2A capabilities within certain ecosystems. And regrettably, some proprietary approaches are common as it's early in the A2A effort. What are limitations of A2A? Every rose has its thorn. Every innovation introduces new friction, and A2A is no exception. Data silos and inconsistent schemas still block that seamless best case interaction between agents. Trust across different companies or cloud environments also remains a continuing concern. Should your supplier's agent negotiate directly with yours? Do you trust that? Legacy systems also resist modular integration, making connectivity harder than conceptually promised. And finally, liability and governance questions loom large. Who is accountable when an autonomous negotiation goes wrong? All of these bullets highlight the practical guardrails that leaders must truly install. Trust, governance, and legacy integration are some of the largest barriers to A2A at scale. The message of this slide really isn't that the model fails, it's that success depends on a disciplined architecture and transparent oversight. Addressing all of these challenges early is what separates successful pilots from ones that are not successful and allows for expansion into production-ready ecosystems. Next, model context protocol is one of the most important evolutions in applied AI for logistics. Up to this point, we've discussed how AI can learn, optimize, and collaborate through A2A. But MCP, or the Model Context Protocol, takes this one step further. It gives AI memory. In most organizations, AI runs as a stateless service. Every query, forecast, or optimization starts fresh. It doesn't remember last week's supplier delay or yesterday's corrective action. In a domain like supply chain management, where historical context defines every good decision, that's a major flaw. MCP solves this by embedding continuity, identity, and historical awareness directly into the AI layer. So with MCP, systems don't just process data, they remember it. A procurement agent can recall that a certain vendor's performance dips during the holiday congestion. A forecasting model can retain last year's promotion cycles and adjust for them this season. And a customer service bot can recognize an ongoing issue without rehashing the entire order history. Think of MCP as the memory backbone for every intelligent agent. It allows context to persist across sessions, users, and systems, so every decision builds upon the last. This protocol also improves traceability, which means you can audit why an AI made a particular choice based on what it knew at that past point in time. The message for leaders out there is simple. A2A is about communication. MCP is about understanding. It moves AI from short-term problem solving to long-term reasoning. And as we go through the next slides, we'll see how MCP transforms fragmented insights into continuous self-improving intelligence loops. So as we introduced on the last slide, traditional AI systems make every decision as if they've never seen the problem before. They lack memory of prior events, user interactions, or decisions, so they cannot connect the proverbial dots across time. In supply chains, where patterns like seasonal peaks, recurring port delays, or supplier reliability matter, This statelessness is frankly crippling. The slide's bullets describe the result: limited usefulness in pattern-dependent environments, forgotten histories, inefficiency, increased risk, and mistrust of AI outputs. Think about a procurement model that forgets a vendor's past late deliveries or a forecasting tool that overlooks last year's holiday spike. Each time the system would start from zero, repeating old mistakes. So we know why memoryless AI can't handle supply chains that depend on historical patterns. It doesn't support context, and context really is basically a currency of smart decision making. So what's our takeaway here? Before we can make AI smarter, we must make it self-aware, able to recall what happened in the past and why it matters. And that's truly the challenge that MCP solves. So what does MCP actually provide? It embeds memory, identity, and continuity into AI systems. It gives models that persistent understanding of who they're serving, what's already occurred, and how new information should adjust future actions. Each of the bullets spells out a capability: retaining relevant facts across sessions, sharing that context consistently across workflows and tools, and enabling the AI to know why that history matters right now. In practice, that means a forecasting model that remembers past anomalies, or a support bot that knows your shipment issue began 3 interactions ago. The value here is continuity. AI that behaves consistently and predictably because it carries context forward. Continuity, identity, and memory across decisions. That's the phrase to remember. So MCP is the connective tissue that turns isolated calculations into evolving intelligence that you can trust. So what happens in practice? Well, forecasting agents recall seasonal demand anomalies, so they stop over-ordering. Procurement models remember supplier lead time fluctuations, helping planners anticipate delays instead of reacting. And customer service assistants can track full order delay histories so clients don't have to repeat information. Each of these examples proves that continuity improves accuracy, trust, and usability. These aren't futuristic concepts. These are all being implemented now as data layer enhancements and API memories behind existing AI tools. These context-aware agents learn from the past to improve future outcomes, just as humans do. The business benefit: fewer blind spots, faster learning curves, and measurable improvement each cycle. Imagine every system in your network remembering its last decisions and adjusting the next one accordingly. That's the operational power and the promise of MCP. So moving on to the next step of this, once agents can remember, the next step is sharing that memory. MCP ensures agents exchange context so they don't duplicate efforts or make conflicting recommendations. It's what transforms multiple smart tools into a collaborative decision-making fabric or network. Each bullet describes a governance feature: shared context, prevention of redundant work, traceability of decision chains, and accountability. Together, these 4 create transparency, so leaders can trace why an outcome occurred and which agent actually drove it. The evolution here is truly from isolated tools to a cohesive intelligent network. MCP, again, is, to rephrase, a universal language of memory among agents, aligning decisions across procurement, logistics, planning, and other domains. It's where explainability and auditability intersect, because now every recommendation can carry a digital paper trail. This shared context is exactly what allows autonomy without absolute chaos. So what are the benefits? Continuity, accuracy, and efficiency at scale, stronger explainability, and improved auditability of AI actions. And what are the cautions? Storing that context does introduce privacy and data governance demands, and standards and interoperability in this domain are still evolving. So once again, memory increases accuracy, but demands greater governance and standards. Entities also must decide how long to retain that context, who can access it, and how to secure it on the cloud. The message here is balance. The more your AI remembers, the more valuable it is, but the more responsible you must be with that memory. So with context established, the next leap is expanding an AI's knowledge beyond memory through retrieval. And that's where our next section, RAG, begins. Retrieval augmented generation, or RAG, is the next evolution in making AI systems truly intelligent. A2A gave us communication, MCP gave us memory. Well, RAG gives AI access to knowledge. Most models, even sophisticated ones, only know what they were trained on. Their understanding is fixed at the moment training data is frozen. But the supply chain doesn't stop evolving. Tariffs change, weather patterns shift, suppliers merge, and new regulations appear sometimes overnight. RAG bridges that gap. It allows an AI model to retrieve up-to-date facts from external sources, databases, documents, or APIs, before generating that answer or recommendation. In practice, this means your AI assistant can check today's customs requirements, ESG score, or real-time freight prices, rather than relying on outdated data. RAG transforms these static models into living systems that interact with the world as it changes. And as we transition through this section, let's think about RAG as the difference between guessing and knowing. When a model retrieves before it responds, it delivers a new precision, auditability, and domain relevance. This capability is what turns AI from an intelligent pattern detector into a trustworthy partner in decision making. So why is RAG needed? Well, most AI models live in a closed box. They know what they were trained on, and nothing beyond that. Training data becomes stale quickly, especially in supply chains that depend on current precise information. Regulations, trade restrictions, and supplier conditions change daily. This slide makes that clear. Models trained on static data are always a few steps behind reality. RAG addresses that by equipping AI to retrieve external facts dynamically. The retrieving component searches approved data sources, while the generator uses those facts to create accurate, grounded responses. The last bullet summarizes the entire idea. That retrieval bridges the gap between static training and dynamic reality. Without it, AI risks making confident but incorrect recommendations. In logistics, recency equals reliability. Static models might know what the rule was last quarter, but a RAG system knows what it is today. So there are two main components to RAG. The retriever locates relevant information from a knowledge base, structured or unstructured data, while the generator sizes that data into an answer, report, or plan. Together, they combine search and reasoning. So the bullets highlight that process. The generator specifically produces context-aware results using those retrieved facts. Answers shift from guesses to fact-grounded outputs, and the architecture adapts that adapts AI to domain-specific real-time needs. So the real takeaway is that RAG fuses that search and generation into one loop of fact-grounded intelligence. Remember that this system doesn't need to know everything. It just needs to know where to look. So the quality of this retrieval layer really determines the accuracy of the output. This is what makes RAG ideal for compliance-heavy, fast-changing environments like logistics and global trade. Compliance and customs. A missed import clause or misclassified tariff can cause multi-day holdups and penalties. This slide illustrates how RAG solves all of that. AI retrieves the latest import-export documentation automatically and generates compliant forms pre-filled with the correct data. It drastically reduces delays for missed clauses and ensures accurate terms and liability assignments. Each of the bullets points to that same conclusion. Automation through retrieval shrinks compliance risk. I mean, imagine your customs team had an assistant that knows every regulation, checks every field, and never gets tired. That's essentially what this automation does. But it is important to remember that RAG doesn't replace compliance officers. It gives them perfect recall. They're still in charge. And the more complex your trade network, the greater the payoff from retrieval-based AI. Remember, lastly, that compliance precision equals both speed and cost savings, two metrics that every one of us can understand. RAG's value extends well beyond customs. Here we look at two critical domains, supplier evaluation and tariff management. RAG-enabled systems pull the latest sanction lists, ESG ratings, delivery histories, ensuring procurement decisions rely on the most current and credible data. Vendors can be scored dynamically, not quarterly. And for tariffs, the system retrieves real-time HS codes and trade restrictions by origin-destination pair, eliminating guesswork in pricing or routing. These use cases prove that supplier risk and tariff complexity demand live, fact-based intelligence. Just imagine, if a company imposes a new export limit overnight, your RAG-enabled platform can update routing and supplier choices before you show up in the morning. And that truly is the operational difference between being informed and being blindsided the next day. So here's the final slide of our section, and it describes the technology stack. The retriever searches index knowledge bases and databases. The generator synthesizes that retrieved context into meaningful outputs, summaries, recommendations, or actions. Supporting tools include vector databases for similarity search, orchestration layers like LangChain or Llama Index, and LLMs such as GPT or Claude as the generator engine. That last bullet really sums it up. The strength of RAG depends on the quality of its retrieval layer. Building this strong knowledge base is not optional. It's really the foundation for reliable AI. This architecture we described so far allows organizations to keep their models lean while feeding rich current context. And for managers, the message is simple. Don't waste your efforts retraining every time the world changes. Teach your AI how to find out what's new. And that's the scalable future. Let's talk about benefits and challenges and the balance of those. Yes, it raises the bar in accuracy and trust, but as always, it also introduces new technical and governance considerations. RAG does provide accuracy, auditability, and domain adaptation. Because answers are based on retrieved verifiable data rather than static training sets, the model can cite sources and explain its reasoning. For logistics people, That means shipment updates, tariff codes, or supplier metrics pulled from live systems, not from memory. This traceability makes every AI decision easier to validate, which in turn drives user confidence and regulatory acceptance. And then secondly, it enables compliance in high-risk regulatory environments. Think customs filings, export controls, ESG disclosures, or product safety documentation. With retrieval, the AI checks current rules and fills in the correct clauses automatically. That precision translates directly into fewer delays, fewer fines, and cleaner audits. And the third bullet, latency. Each retrieval step adds milliseconds or seconds as the system searches, ranks, and integrates external data. That overhead must be optimized through caching, query routing, and efficient vector search. For mission-critical logistics decisions, architects must design a system that strikes the right balance between speed and factual grounding. Sometimes slightly slower, but always correct, is the better business trade-off. And lastly, security and access controls become non-negotiables. When models retrieve from corporate data lakes or third-party APIs, every transaction must honor permissions, encryption, and compliance boundaries. Sensitive data, meaning supplier pricing, trade routes, customer contracts, must never leak between queries. Governance frameworks and audit logs ensure transparency. The conclusion here is that RAG improves accuracy, transparency, and compliance, but it comes with real and substantial design costs in latency, security, and governance. But if you handle those well, you gain an AI system that's both trusted and truly transformative. Graph RAG. This next section marks a very important turning point. We saw how retrieval augmented generation, or RAG, allows an AI system to pull the most current facts from external data sources. But in logistics, facts rarely live alone. Every shipment, supplier, port, and regulation connects to hundreds of other moving parts. To reason effectively, the AI has to understand relationships, not just retrieve snippets of information. And that's where graph RAG comes in. Traditional RAG, or retrieval augmented generation, sees the world as flat. One paragraph, one record, one query at a time. Graph RAG adds depth. It turns those fragments into a network of meaning by representing data as nodes and edges that describe how things influence one another. So in a supply chain, that means understanding that a single vendor supports 5 products, that those products depend on one critical material, and that a port closure around the world can ripple through every customer order downstream. So with graph RAG, retrieval becomes relational. When the AI searches, it doesn't just pull isolated facts, it follows links, tracing cause and effect through the network. The output here is not a static answer, it's a map of dependencies that explain why a disruption matters and where it spreads next. For planners, that means earlier warnings and faster mitigation. For sustainability teams, it means seeing carbon exposure across supplier tiers. And for executives, it means genuine system-wide visibility. This really is an evolution from information to insights. Regular RAG, again, tells you what is happening. Graph RAG tells you why and what else will be affected. It's an architecture that gives AI the same connected awareness that human experts rely on, but at a digital speed and scale. In the next few slides, we'll unpack how this works, why it matters, and where it delivers the greatest impact. So, just as a review, Traditional RAG treats information as a collection of flat, isolated chunks. And that works for text retrieval, but it breaks down when applied to something as relational as a supply chain. Supply chains are not lists, they are networks of dependencies and interactions. Every supplier connects to multiple products and ports. Every regulation ripples through trade lanes and partner networks. GraphRag was created to solve exactly those problems. It models not just the data points, but the relationships between them. Nodes and edges, suppliers and customers, ports and warehouses, contracts and shipments. This approach allows AI to reason across dependencies, not just describe isolated facts. So, when a disruption hits one node, the model can then trace every linked node downstream, predicting inventory shortfalls, lead time impacts, and customer effects before they occur. Think of GraphRag as the connective tissue that turns supply chain data into a living map of cause and effect. It supports reasoning across risks and flows, allowing decision makers to simulate a what-if scenario and choose resilient paths forward. What's important to remember from this slide is that final bullet. GraphRag lets AI reason across relationships, not just retrieve data. It moves AI from reading documents to understanding systems, which is precisely what supply chain management requires. So why do they matter? Well, supply chains, as we discussed, are inherently networked systems. One supplier produces dozens of components for different products and customers. A single port delay can trigger cascading shortages across regions. Regulations might apply only to certain trade lanes, commodities, or SKUs, but the downstream effect touches entire fulfillment networks. Traditional flat models can't capture this complexity because they view each record in isolation. This graph-based approach explicitly models those dependencies. So each node, once again, supplier, product, facility, route, connects through labeled relationships that define how risk, cost, and opportunity can flow. This enables AI to reason holistically. If one port goes offline, which customers are impacted, and which suppliers need alternate routing? Which orders will miss promise dates? And what's the best reroute path to minimize the disruption? The power of GraphRag is that it mirrors the real world's connectedness. So when your data reflects real operational relationships, your insights become almost immediately actionable. This network reasoning reflects the reality of interdependent supply chains. It's not just an analytical advantage, it really is almost a prerequisite for resilience. So let's look at some GraphRag applications. Disruption analysis. If a storm closes a port, GraphRag can identify all shipments, suppliers, and customers at risk and map the ripple effects. Or strategic sourcing. The system can traverse supplier networks to recommend resilient configurations with minimal risk overlap. Or compliance mapping. New regulations can be traced directly to affected SKUs, trade lanes, or suppliers. Or lastly, inventory optimization. By understanding upstream and downstream relationships, the AI can balance stock more efficiently across nodes. So each bullet basically illustrates the same point, that reasoning across relationships turns reaction into prevention. And instead of discovering problems after the fact, GraphRag surfaces vulnerabilities as soon as a connected node changes. GraphRag identifies those ripple effects and reveals resilient alternatives. It is exactly what executives really want to hear. It's not abstract theory. It's a live tool for stress testing and adapting complex networks. Here we get a little technical, but hopefully we stay accessible. GraphRag fuses knowledge graphs and retrieval pipelines into one reasoning system. These knowledge graphs define nodes. And as we touched on earlier, these are entities such as suppliers, SKUs, or routes. And edges. These are relationships such as ships to, depends on, or is governed by. So the retrieval process traverses these graphs, these nodes and connections to fetch those connected facts and not just keyword matches. That context of the nodes and the connectors are then injected into the large language model, which then produces reasoning grounded in the network, not that isolated text. And of course, event streams and APIs continuously update the graph accuracy, keeping it aligned with live operational data. Now, if you'd like to explore more, there are tools such as Neo4j, Amazon Neptune, and LangChain that make this integration practical today. This architecture enables that relational intelligence so that when a single data point changes, the system recalculates dependent variables automatically. In short, GraphRag gives AI context with structure, letting it reason like an analyst who understands cause and effect across the entire supply web. The benefits and barriers. The benefits, as we saw, are significant. It enables holistic insight and system-wide risk modeling, so you can see interdependencies clearly. It also offers explainability by tracing how linked nodes contribute to a recommendation. Every AI conclusion can be followed directly back through a chain of relationships. It also supports proactive mitigation by simulating choke points, emissions exposure, or geopolitical disruptions before they escalate. Barriers, there's always barriers. Building this graph requires robust master data. You can't model relationships without clean entities and consistent identifiers and data harmonization. Across large networks often depends on heavy computing resources and optimized graph queries. Just think about this. GraphRag offers, frankly, the most complete lens on supply chain behavior available today. But its success depends on very disciplined data management. So when it's executed well, it's a difference between seeing a snapshot, a fixed time snapshot, and seeing a system updating in near real time. And that's where you can win today. We touched on data harmonization slightly, but in section 6, let's jump right in. Let's move on to just the data harmonization. Every architecture we've discussed so far, A2A, MCP, RAG, GraphRag, depends completely on clean, consistent, connected information. And without that, even the best AI becomes just guesswork, and you can't trust it. So before organizations can scale that intelligence, you need to harmonize your data. Advanced AI is only as good as its data inputs. You hear that all the time. When shipment IDs, supplier records, and product codes don't align, the AI cannot connect events or spot patterns. This fragmented or inconsistent data produces unreliable results, predictions that drift, dashboards that contradict, and automated actions that miss the mark. Every duplicated supplier name or mismatched SKU erodes trust in the entire system. So data harmonization is the process of restoring that trust. It means unifying formats, establishing shared common identifiers, and reconciling multiple versions of truth across business units. It's the difference between a data lake and a data swamp. When each record speaks the same language, the AI models have a coherent picture of the entire enterprise. That's why we often think that without harmonization, AI's potential remains theoretical. The smartest algorithm cannot overcome conflicting inputs. So think of harmonization as building the digital backbone for intelligence. It turns disconnected data sets into a single validated source of truth that every agent and application can rely on. And once that foundation exists, you can deploy your AI with confidence, knowing that what it learns, predicts, and recommends is grounded in absolute reality. This next section walks us through common data challenges, the technical stack that supports the harmonization, and governance practices that keep it sustainable. Data is not glamorous, but it's the most powerful advantage you could start with. Analytics, optimization, multi-agent coordination all collapse when foundational data is fragmented. So this slide highlights why shipment IDs, supplier records, product codes must align perfectly across platforms. When they don't, an AI may think it's tracking 3 different vendors when it's really one, or interpret a delayed container as an entirely new order. This fragmentation multiplies errors downstream, sometimes exponentially. This inconsistent data produces these unreliable results because AI models depend on correlation. If 2 systems describe the same shipment differently, the algorithm can't learn true cause and effect. Decision quality then erodes. And that's why harmonization becomes the most strategic investment you can possibly make. It transforms chaotic data into a shared, trusted reference point. Once information is aligned, every optimization, from forecasting to routing, improves immediately. Without harmonization, AI's potential, as I said earlier, really remains theoretical. The model might look sophisticated, but the inputs are contradictory. Harmonization provides that exact discipline that turns noise into knowledge. Or you can rephrase it as AI is only as smart as its weakest source. So clean, harmonized data doesn't just improve accuracy, it's what makes the whole effort possible. What are some common data challenges? Well, every enterprise, global enterprise and even smaller enterprises, face the same structural obstacles. Multiple versions of truth exist across departments. Sales, procurement, logistics, and finance all maintain separate systems. Locations and product codes are labeled differently. Metadata is missing or inconsistent. File formats vary from spreadsheets to APIs to legacy EDI feeds. And often, there's no shared business directory linking them together. So each of these bullets is a recognizable problem. Inconsistent labeling of locations and products means Los Angeles Port, LA Port, and Port of Los Angeles all appear as separate entities. Missing metadata means no timestamp, so the system can't tell which record is current. Each one of these small inconsistencies compounds until decision makers lose faith in analytics. So the goal here is awareness. Everyone listening will recognize at least one of these issues in their own organization. It's incumbent upon me to reinforce this point, maybe one of our more important points for the day, that inconsistent data undermines trust, not only in systems, but in the leadership's ability to act on these insights. True harmonization restores that trust. So what are your steps to harmonization? Well, first of all, it's not a single IT project. It's an ongoing governance discipline. The first step is to audit and catalog all key data. Know what you have, where it lives, and who owns it. Next, standardize naming conventions, units, and identifiers, so each data set can speak to the others. A kilogram is always a kilogram. and a vendor ID is universal across all your systems. Then integrate via APIs or data lakes for near real-time synchronization. Static batch transfers are no longer enough. Event streams keep systems consistent as the data changes. And then finally, establish ownership and governance. Each domain, whether it be suppliers, shipments, SKUs, must have a clear steward accountable for data quality. Then repeat that summary line. Harmonization requires audit, standardization, integration, and governance. Audit, standardization, integration, and governance. These four actions form a continuous loop. And when maintained, AI systems operate on trustworthy, up-to-date information. Without that, the intelligence layer decays and trust erodes. This slide describes data discipline and enabling technologies. So let's start with data lakes, which consolidate massive, diverse data sets into a single scalable environment. They provide unified access at enterprise scale. ETL tools extract, transform, and lead, move and reshape inconsistent data so it fits a standard schema. MDM, or master data management, enforces that single version of truth for critical entities like suppliers, sites, and materials. It's a control tower for identifiers and hierarchies. Then API gateways and event streams synchronize data across systems in real time or near real time, ensuring that every change in a source propagates through the network. If you tie these components together as an integrated architecture, the data lake for storage, ETL for transformation, MDM for consistency, and APIs for connectivity, you will form the modern infrastructure needed for AI-ready data flows. Once again, this is not optional. This is a foundation that allows all later AI investments to scale reliably and compliantly. Now let's touch on some examples and risks. Real-world examples validate this. P&G unified over 100 data feeds to enable daily AI-driven forecasting, turning past batch planning into a continuous optimization. Maersk, the shipping company, built a digital twin of its global container network. It only worked because every shipment and vessel record shared the same schema. Unilever harmonized ESG, financial, and logistics inputs, allowing its sustainability AI to connect emissions data directly to procurement decisions. It's important to proceed with caution. Organizations that skip this harmonization face hallucinations, duplicated records, and compliance failures, as we talked about in previous slides. For when they pull inconsistent data, AI can generate very confident but wrong outputs. Exactly the kind of error that destroys trust. So harmonization really is your first step. And it's probably undervalued. It's invisible when it's done right, but absence of it shows up everywhere in bad forecasts, mismatch inventory, and frustration. Section 7, challenges and risks. So now that we've covered the architectures that make supply chain AI work, A2A, MCP, RAG, GraphRag, and the harmonized data layer, it's time to talk about what can go wrong. Every transformation introduces new vulnerabilities. The same intelligence that accelerates decision-making also magnifies any weakness in data quality, governance, or organizational readiness. This section focuses on 5 categories of risk: data integrity, transparency, people, integration, and security. None of these are purely technical, they're socio-technical. They involve culture, process, and accountability as much as code. The first lesson is that AI doesn't remove human error, it scales it. So if those inputs are inconsistent or biased or wrong, the model will replicate those errors across every decision. We'll also look at the black box problem. Many deep learning systems make accurate predictions without explaining how. That lack of transparency undermines trust among operators and regulators. Now we'll also explore adoption friction, how fear of displacement or misunderstanding can stall projects that are technically sound. Finally, we'll examine integration complexity and cyber risk. As systems connect in real time through APIs and autonomous agents, new attack surfaces appear. Data must flow freely, as we know, but it must flow securely. So it's important to remember AI risk isn't something to avoid, it's something to govern. Organizations that manage it best will scale faster and more safely than those that pretend it doesn't exist. So let's move on to look at each risk in turn. Data quality and governance. AI efficiency depends entirely on consistent, reliable inputs. Poor data quality guarantees poor performance, no matter how sophisticated the algorithm. Inconsistent data yields inconsistent forecasts and unreliable reports. Regulatory filings and ESG, because information can't be reconciled across those systems. So data governance really is your safeguard. It enforces stewardship, validation, and schema discipline so that the model always works from the verified truth. Governance also clarifies accountability. Someone owns each data set's accuracy and refresh cycle. And with that, AI insights degrade quickly. Black box concerns. Deep learning models are, by their nature, opaque. They process thousands of variables through layers of weights we can't easily interpret. Operators see the output, but not the reasoning. That opacity degrades trust. And when a user can't explain why an AI made a certain call of rerouting freight or rejecting a supplier, they hesitate to act on it. Regulators, likewise, can challenge systems that they can't audit. This is why explainable AI, XAI tools were formed. They log decision paths, highlight influential variables, and visualize causal relationships. Think about it as giving the AI a black box recorder. The logs and interpretability dashboards don't slow the AI operations. They speed adoption by proving the reliability. So explainable AI tools are an interesting add-on. Technology often isn't the biggest barrier to AI, it's people. AI disrupts routines that have existed for decades. Employees fear automation will replace them, not augment them. That anxiety fuels passive resistance, and very often spreadsheets, manual workarounds, or they just refuse to use the new system. The solution here is to change management built to talk about augmentation, not replacement. Training programs should show how AI enhances human roles, turning planners into analysts and operators into strategists. When the teams understand that the system is an assistant, not a rival, adoption can quickly accelerate. This human challenge is often bigger than the technical one, and addressing it as early as possible dramatically impacts your ROI. And it's important to remember that transformations often only succeed when people can see themselves in that future state. Now let's get into the plumbing. Integration. This is where many projects slow down. Those legacy ERPs, TMSs, WMSs were never designed for real-time data exchange. They were built for monthly reporting and overnight batch runs. And then we try to bolt them onto AI and expect instant results. Integration takes time and patience. It's not a software problem, it's an architectural problem. We're trying to teach language, and that's why engineering projects can delay ROI. You have some very smart teams spending months mapping fields, reconciling APIs, and debugging middleware instead of showing off the results. And then when we deploy partially, one site here, one business unit there, we fragment the benefits. And the data isn't fully connected, and the AI's visibility and perceived value remains low. There is a solution to this, and it's modular architectures and APIs. Think of it as perhaps remodeling your house room by room instead of starting from scratch by tearing it down. Wrap those legacy systems with modern gateways and use event streams and microservices to bridge the old and the new. Integration will always be the slowest, most expensive barrier to scale, but it's also the most valuable. Once that data starts flowing seamlessly, every insight, every optimization, every predictive alert gets sharper. Integration isn't side work, it's really the foundation of this transformation. Security and regulation. Well, with every great capability comes new exposure. And AI and all those integrations introduce attack surfaces that didn't exist before. New connections, new queries, and new ways for data to move. RAG, for example, gives AI access to live data sources, but every connection is a potential doorway. Unauthorized access can expose trade secrets, supplier contracts, or compliance records. Worse, prompt injections, malicious instructions disguised as normal inputs, can manipulate AI outputs. So we need security baked in from day one. Clear audit trails for every retrieval, encryption for every API call, strict access controls that ensure the right people see the right data, and no one else does. This governance isn't an afterthought, it's part of the architecture. Compliance review and traceable logs keep regulators confident and stakeholders protected. The message here is a simple but a strong one. AI doesn't eliminate risk, it changes its shape and approach. And our job as leaders is to design with that reality in mind. Protect the data, log the decisions, and prove the integrity of every system that you deploy. That's how you build trust and how you scale. So how do we move forward? Well, we start by modernizing the digital backbone. We've replaced batch workflows, those overnight reports and static files, with live APIs and event streams. We shift from monolithic on-premise systems to scalable cloud-native architectures that can grow with demand. Then we unify access. Data lakes become the central nervous system of the enterprise, connecting procurement, manufacturing, logistics, and finance. No more siloed reporting, no more which number is right. We connect every operational layer, that is ERP, WMS, TMS, OMS, CRM, so they share one flow of truth in real time. This is the message for all of our teams. Real-time intelligence demands real-time systems beneath it. Modernizing that backbone doesn't happen overnight, but each step does build momentum. The moment your data does begin to flow continuously, your organization will begin to think continuously. And that's when your AI truly begins to deliver. So modernizing your digital backbone. Harmonize at scale. Build your A to A protocols. Connect your intelligence, identify the processes best suited for autonomous coordination, then develop modular agents with clear domain ownership so each knows its role. Enable interoperability through APIs and shared messaging. That's how agents negotiate safely and efficiency. Then pilot in a single operational domain. Prove it small, then build it wide. Then continuity comes next. Implement MCP to give every agent memory and traceability. Tag every transaction, shipment, and customer interaction with context so the AI knows what came before and why it matters now. And then human and AI collaboration. This is when people come back in. Build dashboards to show what the AI is doing and why. Train your analysts to understand model logic and decision triggers. Define clear handoff points. When the humans are in charge or when AI can act autonomously. That transparency keeps confidence much higher. And of course, remember and reinforce one core idea that the strongest supply chains use AI for leverage, not replacement. Machines handle scale and speed. Humans handle judgment and creativity. And together, they can outperform either working alone. Finally, we close with governance, the guardrails that make this all sustainable. Create cross-functional oversight committees spanning IT, operations, and compliance. Audit your model performance, errors, and overrides regularly. Review legal exposure tied to autonomous decisions. This governance isn't bureaucracy, it's control. It keeps innovation from turning into chaos. This responsible use of AI demands accountability, transparency, and documentation. If you can measure it and explain it, you can govern it. And governance is what turns experimentation into enterprise value. So let's bring it all home. Traditional supply chains were designed for predictability. They ran on forecasts, schedules, and static rules. But the world we operate in now, it's anything but predictable. Energy shocks, weather extremes, geopolitical shifts, volatility is a new normal. That's why the model is changing. We're moving from static processes to adaptive frameworks, systems that learn, communicate, and act in real time. Think about what we've discussed throughout this session. A2A gave us communication, machines that can negotiate and coordinate across functions. MCP added continuity, a memory layer that lets AI decisions compound over time. RAG brought us accuracy, models that retrieve live, verifiable facts instead of relying on old data. And GraphRag delivered systems thinking, reasoning across relationships, not just isolated records. And the foundation underlying all of those, harmonized data. Because without consistency and governance, none of this intelligence holds together. So when you connect these layers, something remarkable does in fact happen. The supply chain stops being a series of disconnected transactions and becomes a living ecosystem, aware, predictive, and self-optimizing. The most resilient supply chains of the future will also be the most aware, constantly sensing, learning, and improving. Awareness becomes the new competitive advantage. The message I'd really like to leave you all with is simple. AI in logistics isn't optional anymore. It's truly becoming the operating model of the next decade and decades to come. So ask yourself, where can you start building this today? What data can you clean? What workflows can you connect? What processes can you automate? That's really the process. Harmonize, connect, govern, and scale. Thank you very much for listening today. And let's open the floor for discussion. Thank you for joining us today. If there's one thing I hope you take away from this, it's that AI isn't just another technology wave, it's the next operating system for supply chains. The winners in this decade won't be the biggest or the cheapest, they'll be the ones that think in real time. They'll harmonize their data, connect their processes, and let intelligence flow freely from the factory floor to the boardroom. From A to MCP, from RAG to graph RAG, and harmonization. These aren't buzzwords, they're building blocks for adaptive, resilient logistics. At ARC Advisory Group, we believe the future belongs to supply chains that are the most aware. And awareness starts with action. One integration, one data cleanup, one automation at a time. So let's go out and build those intelligent systems. Thank you again for your time, your focus, and your leadership in driving the next era of supply chain innovation. Thank you.